This is an overview on work and energy, which is our next big topic. First of all, there are several different forms of energy. Kinetic energy, which I will usually call K or KE, as does the book. And it is 1/2 the mass times the speed squared. Gravitational potential energy, which I will often call GPE, and the form of that is m times g times h, m being the mass, g being 9.8 meters per second. Easy number 10 meter per second, and h being the distance off the ground. More detail on that later. And elastic energy, which I will usually call EPE, which is 1/2 kx squared. And then over here in the red, I have the associated forces for gravitational potential energy. That will usually be the force of the Earth on the mass m. And for elastic energy, that will always be the force of a spring. And so 1/2 kx squared, k would be the force constant for the spring. These first three forms of energy are mechanical energy. This fourth form is heat or internal energy, and this now is not mechanical. It tends to dissipate mechanical energy. Big example there for us is going to be friction. If you push something along a surface and it stops, its gravitational potential energy hasn't changed the same distance from the above the height of the Earth, assuming it's a level surface. And the 1/2 mv squared it had initially dissipates into heat of the body and the surface, and this heat is internal energy, which is essentially a random vibration of the molecules. So to give you an example of the way energy will work, which I'll talk about a little bit later here, consider the surface of the Earth down here and a mass m, which initially is a height h naught above the surface, and it's being held stationary. It has an energy of mgh naught, and that would be GPE. It has that by virtue of its height above the Earth. If that is now dropped, if that mass m is now dropped on its way down to the ground, its energy is now the sum of mgh plus 1/2 mv squared. And so one of the key ideas we're going to talk about here is the fact in this scenario that as the height decreases from h naught to h and the GPE decreases, the kinetic energy increases. We all know as something is dropped, its speed picks up. And so what we will see is that the sum of the gravitational potential energy, the GPE, and the kinetic energy, the KE, are constant, with the assumption that we ignore air resistance. Okay, another key idea we're going to talk about here is the idea of an isolated system, and that means a system, and this would be for us an assemblage of masses that do not interact with anything outside itself. And usually that's an approximation, but we'll see examples of that as we keep talking. And then in an isolated system, the energy is conserved, which means that the sum of the kinetic and the gravitational and the electrical potential energies, these are all mechanical, plus internal energy, are constant. And if the internal energy is constant, and you don't have any dissipative forces, then one can simply say the mechanical energy is constant, the kinetic energy plus the GPE plus the EPE is constant. And so that is an example that we showed up here when we talked about the mass dropping. The next key idea that we need to think about is work, and a definition of work will be in the next in a subsequent mini lecture. But essentially it's a mechanism for transforming energy. If positive work is done on a system, the system's energy will increase. If positive work is done by a system, that system's energy will decrease. And so we need to define exactly what we mean by work and see examples of all of these, and those will be forthcoming.